All right, welcome back to the PE COFF file generator slash file dumper project. As always, here's your reminder that you can help keep these projects going by becoming a supporter. And by the way, I don't always remember to mention this, but if you want to, you can also, for free, go join the newsletter. And we just had an announcement come out. Just yesterday about new stuff. So I am now doing a regular streaming schedule, which means somewhere around this time. It's currently 10:40. Sometimes I'll shoot to get started around 10:30, but it's going to be a little variable. But around 10:30 a.m. at Pacific time, I'm going to be streaming every day, Monday through Friday. Monday, Tuesday, Wednesday, and Thursday, I'll be streaming, main research project stuff. This one. Currently, my main focus is this binary file, object file deep dive, but there will be other stuff. We might spend time on the stat solver again. We might work on the base layer again. Someday, hopefully, we'll get to do some experimental programming systems too. So that kind of stuff will happen on the stream. And then on Fridays, at the same time, 10:30 a.m., I'm going to be doing a new series of 4Coder Fridays. So we're going to be going through the 4Coder code base, reading it, learning from it, critiquing things that I don't like about it, maybe writing a new editor down the line, maybe? I don't know. I've been thinking about it a lot, though, and I feel like it might be possible to convert a lot of the 4Coder code that I don't like into code that I do like, one step at a time. So that's what we've got going on. I've got a comment here I want to look at. Something I noticed on the light version of this page, you cannot see the column header, support, member, and premium. Ooh, you're right. Thanks for the heads up on that. I'll make a note. Okay. With that, let's get on to the main topic today, which is more of the PE COFF generator project stuff. So where we left off, I left this big new thing we need to do, which is unwind. And honestly, we don't even have that in the dumper, right? If I run my dump right now, I don't know what F4 is dumping. Let me check that out first. Run dump. This jumps the generated DLL. Okay. So that doesn't have unwind information anyways, so let's instead dump the test.exe for now. Reload the project. Now we can see we have the exception table, so that's where it starts. That's exception handlers, and that gives us a begin voff and an end voff and an unwind voff. But we don't know anything about what this points to yet. We didn't do that at all. So we're going to start from the dumper, and we're going to go and try to figure out what we would do if we did read from unwind voff. What would we expect to find, and how would we interpret it? To answer that question, we're going to track down, and I think I already have some of the stuff I need here. Masm, extern def. We're going to close this group. Windows API, stack usage, prolog and epilogue. That's not the part I want. I want, it might be here in prolog and epilogue, but I'm not sure. Let me try this. I've got some recommended links off stream that I have. Okay, let's try this. Unwind info. Yeah, we know about that structure. Struct unwind info. Interesting. Let's stick this in here. Maybe this too. What is this? RTL unwind is a function. No, this is like a... I don't want their implementation. The unwind info structure is used to record the effects a function has on the stack pointer and where the non-volatile registers are saved on the stack. Okay. Okay. There's another option here. I've done this before. Here we go. This will help. Okay, so that confirms it. What we have here is the unwind info type. Where do I want this to live? We have exception handling here. Here's the unwind voff that we're going to be tracking down. It's right about here. I didn't get my water. Big Fox, hello. I might need to go get my water. I don't like having only one drink. You know, I need this something with caffeine and something that hydrates. Excuse me. Each of these is a byte. The first byte is this thing, which is like a version and some bit flags that tell us probably what's going on. Gotta track those down. Size of prologue size, count of unwind code. So this would be like code count or something like that. And then this is like the frame register or something like that. It's like the frame register and the low bits and then offset. Followed by N unwind codes, which are shorts. Exception handler. Address of exception handler. Language specific handler data. Function start address. Function end address. Unwind info address. So it's another one of those that we already have. It's another one of these exception handler things in case number 2. descending order of offset in the prologue. Okay. Why is this documentation, like, formatted wrong? Like, why aren't they just giving it to me in tables and, like, types and... It's just weird. For all opcodes except the offset is always a multiple of 8. For the opcodes, save and var, the offset is... The unwind operation code is one of these values. Okay, so we've got... I just gotta, like, pull this over here, I guess, do this side by side for a minute. We've got non-volatile. Oh, that's push non-volatile. Alloc large. Alloc small. Set FP register. Save non-volatile. Save non-volatile far. Save XMM128. Save XM128 far. Push machine frame. And that looks like that's all of them. Why is there 0, 1, 2, 3, 4, 5? I miss a few in the middle. 5 straight to 8. No, I guess not. The reference code over here does have values for them, but I'm not sure where those are coming from. It would be called... Here, you can do a Google search for it. Underscore epilogue. Do you have that somewhere? No. Show me exactly this. Yeah, so you know about this. So we have save XMM and save XMM far as 8 and 9. We don't have anything like save XMM and save XMM without the 128s. These are... These are the things I'm seeing in the reference code that I'm looking at. So I'll throw them in there. Epilogue is 6, and The last one is called spare. I wonder if that's spare as in reserved, not used code, but we don't know. Okay. Now, let's see. Our X list here is going to be PE Unwind. What's a good name for this? Unwind opcode X list. Something like that. N equals C, undef X, unwind opcode X list. There we go. Installing Spotify? I thought you would just run it. No, go away. Actually, a little something soft in the background here. Okay. Alrighty, what are we doing? We've got opcodes. We've got the unwind info. Let's keep reading. So an unwind code is a offset, an opcode, and an op info. Do I want to write that down? Yeah, let's try to encode these things. So a U16 is a PE unwind code. So this is get opcode get op info all right. Okay, here are the flags. When you compare that to the other cases I have here, music is too loud. Where was this? Yeah, this one. Do we have flags here? Like E handler, we were just looking at the E handler, U handler? No. UNW flag, E handler. The function has no handler. The function has an exception handler that should be called. The function has a termination handler that should be called when unwinding an exception. So this is an unwind handler, this is an exception handler, this is no handler. This is chain info. The function entry member is the contents of a previous function table. The function entry member is the contents of a previous function table entry. Okay. But do you have F handler somewhere? Okay. So that's basically non-existent. Okay. So what we're looking at here is that the flags, yeah, so that thing, we don't have that part yet. Let's go do that. So the first 3 bits, so that's OX, that's and 7. Unwind info. Flags. From header. It's like drop 3 bits and take the remaining 5 bits. So that's how we get the flags. Now the flags themselves are PE unwind info flags X list X, and we're looking at, man, they don't even give you the values on these flags right here. Jeez. Okay, so we're looking at a 1, 2, 4. This is marked as goofy foot everywhere I can find it. It's like 2 spots in the internet. This is listed in a few places, but it basically just is the stand-in for a null, no flags. So I don't know why it exists. It's not a real flag. So we're talking about E handler. Come on. It's supposed to be the general interface for dealing with text files built into the browser. Why is it so hard? Okay. 1, 2, 3. Unwind info flag X equals C on def X. PE unwind info flags X list X. Not X, N. Oh. So I've had a little side adventure recently. And, yeah, this now has to be written a little differently. Let's just track down all the places where that happened where I didn't fix it already. Boom. Boom. Keep going. Boom. Boom. We're just catching all of them. Boom. While we're at it, are there any others where I did that? So NP there. Let's see. Where do we have DLL push back underscore NP parenthesis? No matches. Where do we have DLL insert NP parenthesis? No matches. Good. Where do we have DLL remove NP parenthesis? No matches. Where do we have SLLQ push N parenthesis? Whoops. SLLQ push N parenthesis? No matches. SLLQ push front N parenthesis? No matches. Good. SLLQ pop N parenthesis? No matches. Good. SLL stack push N. Here we go. Oh wait, yeah, that one's fine because it stays the way it is. And SLL stack pop and parenthesis, no matches. Okay, so that should do it. Now the code base is converted to the new macros. Ooh, got some comments. Let me catch up here. In very old Windows WDK, SDK, PSDK, there used to be a Word.doc documenting all of this, if I can recall. Oh, really, Balbus? If that's true, that's really cool. There was a literal Word document with the documentation downloaded with the SDK. Imagine that. Filzer says, okay, so I'm doing something super cool and nobody else understands why it's awesome. That is so relatable. That's what existence is all the time. Every day, going through life, doing something super cool and nobody understands. Let's see what you're doing. I've been working with a niche bytecode that has about 205 instructions. That sounds like a good time. That sounds like you're doing something cool. What's the bytecode? Lori Master, at the bottom of that page, x64 exception handling, there's a C example that shows the define flags value. Oh, let me check that out. Thank you. Let's take a look. Exception handling at the bottom. There's some C code. Here's some assembly. Here's some assembly. Here's a C description of the unwind data. Oh, nice. 0, 1, 2, 3, 4, 5. Skip 6 and 7, 8, 9. Nice. 1, 2, 4. Yep, that's the ones I took. Guys, okay. Okay. Alright. Okay, that's kind of nice. This is fine, except that it's doing the same thing the documentation itself is doing, which is that it's not really the real code. So if they have undocumented things like what these people say exists, right? If there's a F handler, if there's a 7 and an 8, or a 6 and a 7, but like people disagree on this is what like the version 1 earlier we were looking at one that was like, oh, version 2 is something different. So this is nice to see, but I think it's about the same as what the documentation already told us. Okay, back to Pilfer's story about the bytecode. It executes within the context of a runtime. The RE tooling assumes instruction order is static. If I reorganize instruction order... Sorry, Twitch is cutting off my ability to read the comment. If I reorder instruction order 0x00, 0x2f, etc., it still works with the custom runtime, but all RE tooling is useless and very confused. What do you mean by reorganize instruction order? The RE tooling assumes instruction order is static. I don't know what you mean by instruction order, I think. Like, if you change the order of the instructions, doesn't that just change the program? Or is there some way that you can change the order of the instructions that doesn't change the meaning of the program but confuses the tooling? Or does instruction order mean something else? So it's like, is there a way to rename all the instructions, like to change the labeling of instructions? Are you basically re-permuting the Ah, okay, gotcha. Yeah. Okay, cool. Sounds like fun. Let's see, what are we doing? Yeah, there are a lot of ways to permute 205 codes. That makes sense. Unwind info. Frame reg. Reg from frame, we'll call it. And that'll just be the low 4 bits, and then unwind info off from frame is that bit shifted by 4, and then the high 4 bits. Well, what if, here's my question for you, Pilfers. What if I like did a statistical analysis on this type of bytecode, and I was able to like do something like figure out what the most common instructions are, and then I was able to scan the obfuscated thing and build a histogram and do the sort of like, you know, when you permute ASCII codes as an encryption method, this is the kind of way you attack it. Is you look at what is supposed to be the most common and second most common and third most common, and you just start figuring out what the mapping is from that. I suppose it depends on how regular the code is. Like, if there are things like push and pop instructions that happen at the beginning and ending of blocks. Right. So once you know those groups, you could start using that to crack more. It's still a cool project. It's a cool idea that you can rearrange your runtime to use different to basically be able to execute encrypted, semi-encrypted code directly. I think it's just because you mentioned that there are so many permutations that it's like going to be so hard to crack that I'm like, well, let's talk about that. Is it going to be? Yeah, it makes sense. It makes sense. Okay, so I think we've done a good job. What about these? What are these? I'm not sure yet. Okay, I don't think we need to know any of that for dumping. Okay, so we have register codes here for unwind purposes. We're going to want that. These are, this says bit, but it really means value. Like we're not giving each, it's not like each bit gets a different meaning. It's not a set of flags. Okay. Uh-huh. Oh, crap. That's pretty good. Boom, 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 boom. No, what is this? Boom. Boom, 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 boom. Finally, boom, 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 boom. There we go. Stop. Okay, what is this new key combo that I keep hitting today? Control Shift Space brings this up. Okay, give me one moment. 1Password has like set up a new key combo that never existed before or something, and it is screwing me over. I need it to stop. Yes, delete Control Shift Space from key combos. Good. Okay. Unwind reg x n equals c p unwind reg x list x. All right, I need to go get my water. Be right back. Okay. Okay, so I think I've grabbed all the info types. So let's see if we can dump this, right? We have our dumper over here. Yeah, we need to dump unwind info. Exception handlers count. So in the image version, we look at a directory. We grab the array of exception handlers, and that's just it. That's just it. So in order to keep going, okay, so we're going to get an unwind info for each of those exception handlers. I think we could do it like this, maybe. Unwind info equals 0, maybe? Because I'll just have a pointer to this. That'll give me access to version, flags, prologue size, code count, frame register, frame offset. And then I can do +4 on that pointer to get those unwind codes. And I know how many unwind codes there are, so I will just take each one, get the offset, opcode, and info from each one. I can print the opcodes. I can print the info. I won't be able to print this yet because I won't know when it's appropriate to use the register values. But I'll be able to print the opcodes, offsets, and raw versions of the info. Yeah, that should work. Nice. Unwind V off. Okay. Exception handlers x86i dot unwind V off. And we want to say, okay, that plus the size of and unwind info needs to be less than the loaded data size. Then we can do unwind V off. We can grab a pointer to one of these from that. And we store that into our unwind info at slot I. Blah, 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 blah. Get out of here. Okay. So now we can dump the exception hand or the unwind info part. Okay. Okay, so if we have unwind info, then we're going to print unwind info version equals %d flag flags equals percent OX to do mnemonics. Prolog size. Code count. Frame off. Okay. Unwind info version from header. Header version from header, flags from header, Okay, so now we're getting unwind info. These are all going to say version 1. That's what it said to expect. Prolog size 10, code count 1. Do we get anything that looks different? Yeah. Prolog size 16, prolog size 10. Begin V off, end V off. Prolog size. Okay, so that gives us. So there's, okay, right here, for instance, there are 34 bytes. The first 10 are prolog. And we get a code count of 1. We're going to need to print the codes. $22. I have my chair set up in like super comfy mode right now, so I keep wanting to, tilt back really far and slouch. Gotta like fight the urge to do that. Get myself adjusted back into upright mode for streaming. Okay. Let's focus on the codes first. All right. Excuse me. Offset, opcode, info. And we can do mnemonics here too. Cool. So these are different here and there. We're getting 4s and 2s, 10s and 16s. Here's one with 2 codes. Interestingly, these seem to start after the prologue, which seems surprising. Now these go in before the prologue. 16, 12, 11. This is more like what I would expect. These aren't sorted the way they're supposed to be, as far as I can tell. These seem correct. Descending offsets that cap out at the top of the prologue. Oh, this isn't correct. 19, 17, 22, 21. Seems off. That's all I'm saying. The frame register and fixed stack allocation fields must have the same values as in the primary unwind. The frame register and fixed stack allocation fields must have the same values as in the primary unwind register. Okay. Okay, so it's possible that some of these are not. Number of slots in the unwind codes array require more than one slot. Okay, just because we have 2 slots doesn't mean each slot. Okay. I see. Damn, okay. Okay, how do I want to do this? So the problem is, depending on what opcodes we see, we may have to consume more than one of the slots. And this count tells us how many slots to expect, not how many total codes to expect. I think the easiest way to do this is going to be we could just pre-process it and make a chain. We would have to build dump or unwind info. Let's do it. Save a non-volatile integer register on the stack using a mob instruction instead of a push. This code is primarily used for shrink wrapping, where a non-volatile register is saved to the stack in a position that was previously allocated. The operation info is the number of the register. The operation info is the number of the register. The scaled by 8 stack offset is recorded in the next unwind operation code slot as described in the note above. Save a non-volatile integer register onto the stack. The long offset using a move instruction instead of a push is coded in. The operation info is the unscaled offset is recorded in the next two unwind code slots as described in the note above. 128 bits of a non-volatile X9 register on the stack. The operation info in the number is the number of the register. The scaled by 16 stack offset is recorded in the next slot. The unscaled stack offset is recorded in the next two slots. Okay, cool. Unwind info is going to get modified now to this. All right, now we have to decode all those codes. So we've already done the math for clamping it properly. Except we don't know how many codes to consume until after the, yeah. So we're going to switch on, let's see, for each code pointer, we want to get the op code offset. Yeah, we want to get all this. So this is U16 code equals D reference to the code pointer. We get all the stuff we need. We switch on the op code. Lame. Oh, lame. I can't just use a table because one of them is variable. Look, this one is 2 or 3. That's so lame. If they'd all been a fixed size, right? If this had just been 1 and 11 or something, right? 1 for this and 11 for this. Then each of these would be a fixed size, and the amount of extra nodes we would need would be just a table lookup. But as it stands, I have to do something like this. Okay. For each of those, let's put this over here. I just need to put this window over here so I can see the number of nodes. Non-volatile is a 1. Alloc small is a 1. Set FP-reg is 1. Machine frame is 1. We don't know about these. I'm gonna take a guess. Okay. Now, alloc large is 2 or 3. We have to look at if op info is 0, then the advance is 2, otherwise it's 3. Save non-vol is 2. XMM128 is 2. And these ones are 3. And so then, if advance is greater than 1, then we're going to increment by advance. Now we want to set x. Now x is going to be like this. We're going to read into X from code putter +1 X size. We have to make sure that code putter +1 plus X size is less than or equal to code OPL. So if code putter +1 plus X size fits into our legal range, then read out of that range into the X a little endian yeah. Finally, extract fixed size op stuff. Determine how many slots to advance. Read extra field from extra slots if possible. Form the unwind code. Advanced code pointer. Okay, that's it for that part. So form the unwind code, put it onto the list, increment the code count. We also need to fill in the unwind code. Luckily, that part is easy. We've already prepped for that, right? We got offset opcode op info sitting up here. So these are just pre-known. And this is just a dump loop. We don't need to do any processing. Okay, for each code, we want to print something like this. So that's empty now, which is not right. It says code count equals 0. But that comes from the fact that it didn't do this, apparently. Codes clamped count should work. That should happen, right? Code putter. Unwind info +1. Well, sure. How can it not be there? It just doesn't make any sense to me. The unwind info is filled up correctly. Version flags, prologue size, code slot count must be correct. Ah, here's our problem. P unwind info code count, please. There's one. It's all zeros, but at least it's one. Code count equals 2. These are all zeros as well, but maybe if we go and try to fix that, we'll be better off. So what's going on here? Why are you giving me all zeros? Unwind code should be filled with real information. Yeah, how is that not filled with real information? That doesn't make a lot of sense. Remedy. Let's open up the project for dump. Step in there. I'm looking for somewhere around unwind code x equals x. So line 678. Can we go to 678? Breakpoint there. Oh, you need me to probably dump something different than what you're dumping right now, right? Yeah, test exe. Someone who actually has some unwind info in them. Fine. Good. How are these all zeros? Code is 0. Code putter. Unwind info. Oh, you know what? I can't do it that way. Because that's not real anymore. This needs to be loaded data dot string. Well, this could be PE unwind info plus 1. That's what would work. There we go. Now, if we look through all of the unwind infos, sooner or later we'll find one. Okay. Next, center, done. There. 30, 23, 22. Yeah, those are in the right order. Yeah, all of these seem good now. Do we have somewhere x equals something other than 0? That would make a lot of sense if we did. But maybe we don't. Hey, there's one. Okay, sure. Nice. Okay. So now I think it's right. These all appear to be following the rule of being in descending order. They're all within the prologue, which is what I would expect. Very nice. Okay, I think this is a good spot for a midstream break. How far are we into this? An hour and 40 minutes, so we're not going to do a whole lot more today. We're pretty much going to be calling it done, but I think this is finished. And what's next when I get back is to talk about plans for generating unwind and exception info into our generated program file. So let me take my break. Let's see, do we have Milton up? We don't. We're going to do it with forecoder then. Let's exit out. We can save. No, not you. Save this and close. Pull up a new forecoder. Close panel. Zoom in. All right. Be back in a minute. All right. I want to look at the Unwind info layout in ImHex first. Slot number 3. 208-896 5844. Two zero eight eight nine six 5844. So it feels like the P data is exclusively containing the exception table. And that leads me to wonder where the unwind info is living. So let's say I look at this even more carefully. V off for the unwind information is 187616. 2DCE0. Okay, so we need to go and figure out what section that is. It's not P data, right? 187. No, it's got to be sooner than that. Could it be in R data? 135. Yeah, and that has a size of 60K, so it would contain this 187616. So 187616 minus 135168. 135168 plus 130560. 183008. And that as a hex is 2CAE0. And these are going to look like unwind info. A header, version 1, no flags. A prologue size, 10. A code count, 1. And a frame, 0. And then a code, 2 of these. And then, I guess it's aligning to a alignment of 8 or 4 maybe. Maybe these are null codes. Have to go and figure out what exactly that is. But there's our code. Offset 10. Opcode 2. Opinfo 2. Opcode 2, opinfo 2. Yep, there it is. A Montirome? I'm not sure what your question is. What name your terminal? You mean just this thing? Like the standard Windows command line thing? Or do you mean the text editor here, Forcritter? This here is not a terminal. In case that's not clear. Okay, so so the task is to generate this. And so we have the type structure we need. We need to probably define a constructor for it. And that's debug info right there. So I'm curious if we look at our data. We find this the beginning, the lookup table. We find debug data here. Here's where we find the beginning of those unwind info. And here we're finding the import table stuff. Yeah, and there's the strings for it. And then we've got actual data section right here, I imagine. Yeah, okay. Okay. One other thing I want to get straight. There's something that comes after this is suggesting that there's a whole other thing after the unwind info, but that can't be right. So if we have a U long here, that's an address of the exception handler. That would correspond to 4 bytes. Right here we had these two. This would have to be a U long, but it's not. Right, we like immediately get the next opcode, the next unwind info. Here's the unwind info. Here's an opcode. There's no sign, yeah, or an unwind code. There's no sign here of a U long. I mean, there's 2 bytes here. Yeah, this part just seems wrong. It says that there's going to be one of these or one of these. It doesn't say how to know which one. And when I look, it doesn't seem like it could be either one of them. I don't see any easy way to resolve that question right now. It's going to be a whole digging thing that we have to do. What are the rules on alignment of unwind info? What? But let's at least sketch out the part that we know we can do correct right now. Okay. Okay, I think we'll stop there. So I've sketched out basically the idea. And the next big step is to create the API that would let me fill in these and see if I can get that working. And if I can, then the next step after that would be to bake it. And of course, I have to get these questions answered too. So that's what's coming up. I might do some of the question digging research off stream since I'm a little not jazzed about that. I might do the construction API off stream since I've shown how I do that kind of thing, and it'd be nice to do something easy. But I might also just save it for stream. I'm not entirely sure what it'll be like. With that, I will once again, for anyone who's here who didn't see the beginning of the stream, I'll remind you of a couple things. One, you can support the project and everything going on at the Mr. Forth Lab if you go over to mrforth.com/membership. And there are a lot of cool perks to being a supporter or a member, and you also are contributing to keeping stuff like this going. In addition, I have announced recently some upcoming stuff going on this month. So right now I'm doing a weekly stream or a daily stream every week. So I took yesterday off, but I'm doing Monday through Friday, 10:30 a.m. my time, so Pacific time, every day, Monday through Friday. There will be a few days off in the middle there. And on Fridays, I am going to be streaming 4Coder Fridays, which means I'm going to be going back to 4Coder, reading some 4Coder code, reviewing it, critiquing it, maybe fixing some bugs or rewriting 4Coder at some point. I don't know how far that'll go, but I want to at least start by reading the code and talking about it a little bit on stream. So I'll be doing that on Fridays. Other days of the week, I'll be working on whatever research projects I've got going on. Right now, it's the PE COFF deep dive stuff. We also have the week of the 23rd through the 29th, the Handmade Networks Wheel Reinvention Jam. And so on Friday before that, at 2 p.m., I'll be hanging out to discuss jam project ideas. And then I'll be jamming all week that week. So every day that week, I will stream to the jam stuff instead of the regular research going on. So you've got all that to look forward to. And with that, I will be signing off for today. Thanks for coming and checking out what I'm up to, and I'll see you around the internet. Bye.